That might be an interesting thing. I understand that this is new, but there's sort of, it would be nice to see that. I think that is an interesting relationship. And then I was wondering, could it be that simply the width, that sort of I don't have a good idea if it's a smooth distribution of particle sizes, because the coloring, of course, is very coarse, but it's a smooth distribution of...
It's at the coarser sizes, it is a smooth distribution. At the smaller sizes, it becomes a little more discrete. But there actually, I didn't actually say, but there is a little bit of an overlap between the blue sizes and the red sizes.
Could the width of the channel, with the large particle size, be suppressing the clustering of large particles?
I'd have to think about that. I mean, it certainly could be. Of course, it's also that you need the particle size to be relatively large compared to the width to get step pool type clustering in general.
Yeah. Well, then the walls are helping clustering.
Well, and in this case, certainly I scaled the size of that largest particle to be, roughly a quarter of the flume width. In nature, you see some different numbers for the for these things, but maybe 1/5 or 1/8 of the particle size relative to the channel width to get that.
I never saw a step pool pattern in a braided river.
Yeah. No, I mean, certainly it's true that you need the channel to be narrow relative to the largest grain size to get it.
But the clustering could be looking at one of two things, and one is sort of a lengthwise clustering, and then sort of like a segregation in terms of steps along the way, and then the other is a widthwise clustering or something like that, and you might be suppressing one and not the other. And so is it clear that your L prime is measuring that clustering that happens with step pools and not as clustering that sort of says longer and longer patches? Does that make any sense? I don't know if this makes any sense, but I'm just wondering. That might be something to think about a little bit to see if the width is suppressing one.
I'm always into thinking about these things. The real answer is I'm not sure. I thought about doing the statistic just in the x direction. I mean, at the moment it does do both y and x, and at the very short distances, the y and the x is both in there. The longer distances, of course, it's very much biased towards just the downstream.
Okay, so I have one more very short question about a different thing, and that has to do with what was happening over time when you put in a pulse and you got the coarsening of the bed, and you put in the pulse and you got an additional coarsening of the bed. So this is kind of related to Gary's initial question. Maybe, could it be that, I mean, you don't really have necessarily the steady state condition when starting out. Have you tried starting with a coarser system and putting the same pulse in, and maybe you get some fining, and so maybe that could, you can see if you're approaching sort of the same steady state condition. Is that?
So start with basically start with a different grain size distribution, maybe coarser, and see if see what sort of endpoint I get to. I mean, I think that it's a great question, and I mean, doing sort of things, to put my optimist spin on it, doing things, away from equilibrium and looking at these transitions, in a sense means there's a lot more possible parameter space that you can explore. It's really interesting to see what they get to. I think of these as a little step in that direction.
But maybe a different take on the idea that sending a pulse of fines necessarily coarsens the bed. It sort of helps jostle things around and getting it closer to a steady state, but it doesn't necessarily
fair enough.
That's kind of my thought along those lines.
I can definitely imagine a parameter space exactly where you're starting out coarse enough that you add the fines and it just fines the bed. And that'll depend on the intensity of the flow and your ability to transport the grain sizes on the bed compared to the stuff that you're feeding in. So So I guess I can certainly imagine different responses there. At least here we scaled it roughly to a step-full channel, and so I think it's at least reasonable for some parts of nature.
Thanks a lot.
Thank you.
Better wrap it up now.
Thank you all for the questions. I appreciate them.
One comment I think is relevant here, because there's so much work being done on historical studies, is your initial condition is not like nature. And that unless you want to start with the debris flow as your initial response, because it isn't randomly organized rocks mixed with fines. And so you're still working off your initial condition in experiments. If you go in the field, what you see is boulder stack and boulders, and maybe sitting on bedrock. And I would think you'd have possibly a very different condition, most commonly, than this, because it seems like you're still, as Gary's talking about feeding the dog, you're still sort of working off the condition that you start with a completely mixed system, which you would only create by mass photoplasm. Right?
I think that's true, and certainly I think that it would be. It's good to get feedback. It would be good to, it would be good to start it with a state where we really kind of fed everything in and built up of that.
Yeah. Anyway, so I think we're supposed to get introduction now about the experiments. Thank you.
Thank you.